Alright, so this video is going to go over Git, GitHub, and Unix commands. We'll first talk about Git. Now, there's a difference between Git and GitHub. Git is the version control system by itself. GitHub is that website that you go to that contains a bunch of online repos. We're talking about Git right now, so we're talking about the local repository, which is the repository stored on your machine. Now, Git is a version control system that allows you to roll back to different points in history of your file's lifespan. So for example, let's say I created a file last week and I submitted my assignment and I realized, oh wait, there's a bug in it. So this week I decided to update it and I push it back onto my repository, and then realized in the process of me fixing that bug, I ruined a bunch of other things and I created a bunch of other bugs. And I said, oh no, I want to go back to my previous version of the file. Well, Git will remember what the previous version of the file was and it will allow you to roll back or revert to that previous file. Now it does so by having three different parts to it. There's a working directory, a staging area, and a repository itself. The working directory is that entire directory itself, that file, that folder that you have that contains all the files in your repository. And also more to it oftentimes. And it's basically that if you went on your computer and you pulled up that directory, like in this case maybe C343, that would be the working directory. It includes everything. The staging area we'll talk about later. I'm not going to talk about just yet. And the repository is what's actually remembered by the version control system. So you might not have everything in your repository. There are some files that are called temp files or swap files, which aren't really necessary. You don't need to really keep track of. So the repository wouldn't contain those because it's not important to keep track of it. The repository only contains files that you want to keep track of. So let's say that currently, if we look at our file system here, we have an empty repository, staging area is empty, and the directory itself is also empty. So at the moment, everything's empty. Now let's say I decided to create a file. So there we go. So I have the file myfile.txt. Now at the moment, this file is not known by the repository. I just created it. And I'm going to put a little marker here just to represent that no one knows about it. It's called an unstaged file. In other words, nothing knows about this file at the moment. I just created it, so it's marked as unstaged. It's basically a file that was just created or modified, something like that. Now at the moment, no one knows about it. So if I were to delete this file or change it, I wouldn't be able to roll back to previous versions of it because the repository isn't keeping track of it. So how does a repository keep track of it? Well, repository, what it does is essentially take snapshots of your file. So you can imagine as if you have a file open, it'll take a picture of it and say, okay, I remember this version of that file when I took a picture of it. Now, in order to do so, you first have to put those files in the staging area. Remember, like I said earlier, you don't want to necessarily keep track of every file. So the staging area is essentially a place where you put all the files that you want to keep track of. And when you've put it onto your staging area and you're ready to take a picture, the repository will take a snapshot of only everything in the staging area. So anything you leave out of the staging area, it won't remember. So let's say we want to add it to the staging area. To do so, use the git add command, as you can see right here, this git add right here. Circle it, there we go. Now the git add command, there's a couple variations of it. You can do git add and then space period, and that means add everything that's currently in the directory I am currently residing in. So if I'm currently in let's say I'm in a nested directory, I'll only add the files inside of that directory. There's also git add followed by file name, so you can add specific file names. If you only want to add myfile.txt, you can say git add myfile.txt, and it'll add that file specifically, nothing else. There's also git add all. It's git add space hyphen all, and that all option basically says add everything in the working directory. Everything in there, add it all to it. Let's just say for this example, we just do git add myfile.txt. So in that case, we'll get a file here, and it'll be moved to the staging area. Whoops. Let me do that. There we go. So we currently have this here. And because this is now here, it is no longer unstaged, so that red mark can go away. So I'll erase that red mark. Don't need that anymore. All right. Oops, I actually erased more than I meant to there. All right, so the red mark's gone now. Okay. And at the moment, it's still not known by repository. The repository doesn't actually know anything about the file. It hasn't actually stored it in its version control system. To do so, you do git commit, and basically the git commit command basically says, take everything in the staging area, and I want you to commit that to memory or commit it to the version control history. Now, git commit is always followed by a message command. To do so, you do git commit space -m space, and then inside of double quotations, the message for that commit. Basically, you're giving a little comment that says, okay, hey, in this commit, I uploaded myfile.txt, or hey, in this commit, I fixed bug in number 23, something like that. So in this case, let's just say git commit -m added myfile.txt. In that case, we will then move this over to here, like that. And so now the repository has in its version control history myfile.txt. Now notice, of course, the original myfile.txt over here, which actually is, since it's also been staged, I should erase that markup here as well. It's still here. It's still located in this area. It's still located in the working directory, right? It's not, you're not erasing it when you add it to repository, it's just saving it to the repository. And also now that this file has been added to the repository, it's no longer in the staging area, so we can remove that. In other words, you took a picture, so you're like, okay, I'm done. I took the picture. I don't need to keep everything in the staging area. So we can get rid of that now. All right. Now, let's say I go and I start changing something in my file.txt. So that was my first upload. Now, when I change something about it. In that case, once again, because I've changed it, it is now modified again. So we'll add a little asterisk here again. And so because of that, the repository doesn't know about it. So what we need to do is, and actually I'll call this a version 2, just to make this a little clearer. I'll call this myfile.txt, I'll call v2. Let me rewrite that. v2, there we go, right? What's going to happen now is I'm going to add it to the staging area, so git add myfile.txt again. So let me duplicate that. And we'll move it over to the staging area. All right, and because it's in the staging area now, it is no longer marked as unstaged. So we can erase this red mark, and the same goes for this file here. Okay, and now I say, okay, I updated it. I'm going to add it to my repository now. Git commit it to the repository. So I do that, and essentially what happens now, let's duplicate that again, comes over here. Now repository can remember that there's myfile.txt modified version, and also remembers the myfile.txt from the previous version, right? So if I ever wanted to roll back to the original myfile.txt version 1, I can always do so because it's still located up here in the repository. All right, so that is how the local repository works, and that should be enough for you guys to understand. Now, let's talk about GitHub, so that online repository. And those are called remote repositories for those of you that are curious. And let's bring that open. So let me pull that up here. All right, so this here is an example of a GitHub repository. And let's say that both of us, you and I, are working on this repo. So I have my own version of it on my local machine, which is this orange box here in my repo. There's also your version on your machine, which is this green box here, your repo. Of course, this could both be yours. It could be both. Maybe you have two machines, maybe a desktop at home and a laptop you use at school, and you have two versions of the GitHub repo here on here and here. All right. So the first thing you need to do is, well, how do you get, let's say like I made this repo and I put it on GitHub. Well, how would you download it? You would do something called git clone. So you would get the link to this repo, and let me pull up a pen here. Okay, and then you would git clone it onto here. So git clone, and then after the clone, you follow it by the link to the repo, which you can find in the clone or download button of the repo. And when you do git clone, it clones that GitHub repo and puts on your repo. Right. So now we're going to assume that you've git cloned it, so both of us have a copy of the GitHub repo. Now, let's say I change something about it, and I want to push those changes onto the GitHub repo, because I've changed it. So now I have, like, let's say a file, myfile.txt here. It's on my repo, and I've committed it. So it's in my repo's version control history, but that doesn't mean it's in the GitHub repo's version control history. So what you do is use a command called git push. So do this, and so once you've committed, you can do git push. And if you have multiple remotes, like it's not necessary that you only have one GitHub repo. Maybe it's connected to two. If you have multiple, you have to give it that name of that. And if you do git remote -v, it'll show up, hey, which repo is connected to, or which remote repos are connected to this repo. I'll go over these commands later in an actual terminal so you guys can see it. This is just an illustration of it. So you do git push, and let's just call this one, normally it's called origin. So git push origin, right? And I'll push it to the origin. So basically what that does is it creates a copy of, or not a copy, but it pushes the myfile.txt and moves it up to there. So let's do that. So now GitHub repo has myfile.txt, right? Now, if you notice, your repo doesn't have it. So if you start messing with something right now and you try pushing to GitHub repo, well, what if it doesn't like it? What if, let's say that, let's say you and I are both editing a Java file, right? And I change something about it and I push it to the GitHub repo. And then you change something about it without me knowing. We don't know about it. So we editing the same file, but we just didn't know that we were doing so. So I push it to origin, and then you try pushing afterwards. It's going to cause an issue, because what if I changed something that you were changing? Like, let's say I changed a line of code, right? And then you kept writing code based on that line of code. There might be issues there, or these are called merge conflicts. And so if you try pushing onto it, a lot of times you'll run into problems. Not necessarily all the time, but there's chances that you'll run into conflicts where I change something that you decided to change too, right? This is why we do something called git pull. Now notice, git pull is different from git clone. Git clone copies the GitHub repo onto your machine. Git pull updates. It takes whatever is currently in the GitHub repo up there and it pulls it down into your repo. Right, so we'll write that out real quick. Git pull. Oops, let me actually write down a different layer. Yeah, git pull. And once again, if you have multiple remote repositories, you do git pull origin or whatever that remote is labeled. And when you do git pull now, it takes that file, duplicates it. Well, not really duplicates it, but it brings it down to your repo here. So now you have a copy of it. And now we are both up to date. Right? So in most cases here for these remote repositories, you guys really only need to know two commands, which is git push and git pull. And this is how this works, right? All right, so I think that'll be it for the illustration. So let's move on to an actual terminal. All right, so now we're here on the desktop. For those of you who are on Mac and Linux, you should be able to already access Git through your standard terminal. But for those of us on Windows, you guys will have to install a program called Git Bash, and that will allow you to access the standard Git commands. To install Git Bash, go to git-scm.com/downloads. When we get that link, hit the Windows install link, and it'll ask you to start downloading installer. I already have it installed, so I'll run the installer now. Pull that open. And so an installer window will pop up like this. Just hit next, next. And then right here, for everything here, just leave it as is. Next, next as usual. For your default editor, it doesn't really matter which one you pick. I use Vim, so I'm going to stick it as Vim. Next. And for this part here as well, just keep it as recommended. So get from the command line and also from third-party software. Use the OpenSSL library. Now this is the part where we make sure you guys have what we have here. Make sure that we check out Windows style, commit Unix style line endings. So don't select checkout as is or any of these other ones. Make sure it says checkout Windows style, commit Unix style line endings. Okay, next there. Here's mntty, that's perfectly fine. And just keep basically hitting next. The only part you had to make sure was the checkout style. All right, so let's let that install real quick. All right, so now we're done. All right, so now that you have Git Bash installed, you can open up Git Bash just by searching for it. And a window like this should show up. You can enlarge the window just by dragging it down here. And to increase the font so it's a little easier to see, hold the control button and then scroll up on the mouse wheel. All right, so before we move on to Git commands, let's talk a little about Unix commands and a couple ones that you'll probably need to know for this class. There's an ls command that stands for list, and what it does is it lists all the files and directories that are currently in your residing directory. So depending on what directory you're currently in, it'll show all of those. Right now, I'm in my D drive, so if I type in ls, you can see a bunch of other program files directory and a users directory, stuff like that. There is also one more command called cd. cd stands for change directory, and it allows you to move into a different directory. So if you want to cd into users, for example, I can do that. And I want to get to my desktop, so you can follow a path. This is called a path. You have users and then /, and then whatever folder you want to go into next, / again, and then my final directory right here. So now if I type in ls, you can see I'm in my desktop at the moment. Okay. Before we move on from the cd command, there's a couple more things you want to know. If you want to go back a step, so let's say that I'm currently in my 343 repository here, right? And I want to go back to my desktop, type cd space ... basically means go up a level, go up into a directory that contains this directory. There's also one more command called, it's just cd dot. Now this won't actually do anything. What dot means is instead of going up a repository or up a directory, dot represents this directory. So of course if I cd into this directory, it doesn't do anything, but you will need to know that for git add in a little bit. Okay. There's also another command called print working directory or pwd. It'll print the path to your current working directory. And this is useful if you're nested many directories in and you forgot what directory you're currently in or you want to see the layout, you can type pwd. In this case here, you'll see it says users, kca01, and then desktop. All right, the next command is remove. So let's say I create a file that I didn't mean to create, right? So let's say I create a temp.txt here. And if I type ls, you can see it's there. I want to remove it. Type in rm for remove, followed by temp.txt. And then if you type else again, you can see it's gone now. Now, what if I make a directory? So let's say I make directory, and this is another command called make dir, stands for make directory, and you just well, it does what it expects to do. It does make a directory, so it's called temp directory. Give it a name. Let's go into that and let's add a temp.txt. There's a touch command. Don't have to worry about that. It is important for you guys. All right. Now let's say I want to remove this directory. What if? So can I do remove temp.dir? Well, no, because it'll say you can't remove it. It's a directory. If you want to remove a directory, you have to do it recursively. In order to recursively, do rm -r. Now, sometimes with some terminals, if you try to remove a file, it'll ask you, "Are you sure?" Now, it's okay if it's only one file you're removing, because you just type yes or type the letter Y, and that's one time. But if your directory has 40 files, you don't want to press yes all the time. So what you can do is you can add another option called rf. So it stands for recursively, and then F stands for force. And force means force the deletion, don't ask me. And if I type temp.dir now, you can see it is now gone. All right, another command is copy, so cp. Basically, if I have, let's create a temp.txt again, and let's create another directory called temp.dir. Let's go into temp.dir. Let's say I want to create, let's say I want to create, or I want to copy the temp.txt file into this. You do cp, and then since temp.txt is currently in the directory containing this, it's up a level. I'll do /temp.txt, and I want to copy it to this directory, so just type dot. If I type ls now, you can see it's here. Of course, that means that the temp.txt is still in the desktop because I copied it, I didn't move it, so it's still there. So what do you want to do if you want to move it? Want to move the file into this directory? Well, first let's remove this other one here. Whoops. Temp.txt. Okay, so let's say I want to move it. Type in mv, and you go back a level, grab that temp.txt file, and then copy it here. You can see it's in here now, but it's not in there anymore. One more thing about copy is that if you want to copy an entire directory, you have to type in cp -r, and that'll copy the entire directory. So if I move this into 343 now, you can see it's gone. It's still here, but if I go into C343, it's also here now too. You can't copy without doing recursively if you want to move it, copy an entire directory. Now with the move command, you don't have to worry about that. Okay. One more last thing about the move command. If you want to rename a file or a directory, what you can do is you call move on it and move it to the same directory it's currently in. So don't move it into another directory. Move it to the same directory it's currently in and then give it a name. So let's call new name. So if I type in else now, you can see I changed name from temp.dir to new name. All right, and that is it for Unix commands that you guys need to know. So you don't have to worry about too many others. Let's move on to Git commands. So with GitHub, there are a couple different options here. All right, so with Git commands, let's go with the first command you need to know. It's git clone. What that does is it essentially downloads a directory or a repo. All right, so the first command you need to know would be git clone, and basically what it does is it downloads a repo online and downloads onto your main machine. So let's say, for example, if you follow your tutorial from the previous video, you can see that you can get the clone link from here. You open up, hit clone or download, make sure it says clone with HTTPS, and then copy that link and do git clone and paste the link right here. So if you type this, you can see that it has been cloned. We have a directory called distribution. Let's move that to a desktop so we don't get confused. So let's go to our desktop now. Okay, there we go. So distribution is there now. Okay, so as we said earlier, let's create a file. Let's say that I go into A2 and I want to create temp.txt. So let's do that. Right? Okay, and let's see. There we go. Now let's say I want to add this to my repository. It's currently not in my repository at the moment. Well, we need to git add and add it to the staging area before we do a commit. You can either do git add dot, which means git add this entire directory, which would work. You could also git add space dash all. That would add everything in your directory to the repo or to the staging area. Or alternatively, since we only made one file, we can do git add temp.txt. For you guys, I recommend doing git add dot and make sure you're in the right directory when you do so. Okay. And then we commit that. So we do git commit m, let's say added temp.txt. And we do git push. And since we have different remotes now, in this case we have two remotes, one to distribution, one to submission, we need to make sure we use the right remote. We have a couple remotes here. One's called submission, one's called distribution. So we'll git push to submission and give it a branch, in this case just master. There we go. And now it's pushed it. So if we go here now and I refresh this, there we go. Added temp.txt. And so it's there now. And of course it's empty. Okay. Now let's talk about git pull for a second. let's say you have on another, let's say you're on two machines. You have maybe a desktop at home and a laptop that you bring to school with, right? So let's go back here and let's simulate that sort of situation. So let me actually remove, so let me double check and see what files are here. Okay, move that. That is not necessary. Okay, so let's just pretend that we're creating our directory at your desktop computer. So let's just say C343 Spring 2020 is your laptop. We want to create it on your desktop. So let's follow that real quick. Git remote rename origin distribution. All right, then git remote add, and we're adding this one here. This just adds a remote for us. So add, and we'll call it submission, and we'll paste that in. All right, so now this is here. And we'll do git pull submission master, and the branch, we can ignore that. There shouldn't be any merge issues. Okay, and git pull which, let's see, the distribution master. This should be updated, so we don't have to worry about that. Okay, so now let's say, look at this, right? We have a distribution. We'll call this, we'll move that one to call it desktop, just to make it easier, desktop. Right? And we'll call it C343 laptop. Okay, so let's say I go to my laptop. Whoops, let's see. I have to open a different file. Okay, then in that case, we don't have to worry about it too much. Let's just go into here. All right, now let's say I change on my laptop. I go into A2 here and I change temp.txt and I add some text to it. So let's say random text, right? If I look, of course, if I look at my desktop directory right now, it's not going to show that because it's only happening on my laptop at the moment. So let's do git add A2. Whoops. Let me go to A2 for a second. All right, git add, okay. Then git commit.m change temp.txt, git push submission master. So it's on here now. If I open up this, you can see that it does say change temp.txt. But if I go into my desktop right now, oops, desktop. Oops, I'm still in the wrong directory here. Desktop, there we go. And if I look into A2, let's show temp.txt at the moment, it's empty. There's nothing in it because, well, it hasn't pulled from the repo online. So we have to pull from it. So we'll get pull submission, saying which remote are you pulling from? We're pulling from submission and pulling from the master branch. And there we go. And we don't have to worry about these. These will be fine. Okay. So now if I go into our A2 now, and this is our desktop directory, and we do what's in temp.txt, you can see there's random text there. So that was perfectly fine. All right, so that should be it for the Git tutorial. So hopefully that helped. If you have any questions, feel free to ask us.